So the previous slots were meant to be for presenting the main differential components from a technical point of view, like showing to you the functionality. Now the next three presentations will be about how we apply actually the platform to three specific companies that are part of the consortium. So the first one being Parmalat. Parmalat is a worldwide well-known dairy company that is able to produce different milk-related products such as yogurts, shakes. They also produced fruit-based beverages. They have quite a lot of plants around Italy. And you can see that those plants that are identified in the very left part of the slide with Colecchio, Fevi, etc., they are producing different kind of yogurts in it. You can see the representation of the different plants here. And within the knowledge, the project was focused on Colecchio. That was the main facility, the initial facility that was founded in 1960. In that specific plant, some of the numbers are that it's 143,000 meters square taken by they produce and they distribute the products. They also distribute the products within the business. So these are the sizes of the area in Colecchio. This is the size of the actual building and the amount of pallets that they produce in average that are hosted in average in the warehouse per year. So when we came to this case, Parmalat was interested in one specific problem that was improving their scheduling process. You know, they were weekly. They gathered the information coming from all the selling points, and they put all that information together in order to try to plan the complete volume of the supply chain that is meant to be covered by the Colecchio plant. And then they upstream that information. First of all, they schedule the packaging line, that is the very last part of the production process, the production and distribution process. And then when they schedule that part of the process, they move upstream and they plan the preparation area, and they plan then with that schedule, they plan the raw material arrivals. And with these three different sources of information, they carry out the actual production for the next week. And then what the main two improvable points that they show for applying the knowledge platform was, one of them was that the scheduling was done with all the constraints in the head of a couple of persons, you know, in the company. That person has a long experience and they are able to understand what is the best option for scheduling the production, meaning that, okay, in order to minimize the cleaning of the machines, then the yogurts that are related with one specific color of a fruit, then they should be put together. And then if we have to minimize the cleaning, maybe I have not to put the raw yogurt because being white, I have to pick a yogurt that has a similar color or things like that. You know, that kind of how it is called technical heuristic. That means that human knowledge is in the head of the experience of 2-3 people, and they do it using that system. And they wanted to externalize that knowledge and to put as a set of rules in some specific system. And the other problem that they were trying to address is what happens if something doesn't work fine. You know, what happens if we have that kind of unexpected events, meaning that if a machine breaks, if suddenly some resources or some strike happens, what happens if we don't have a certain amount of a specific yogurt, things like that. Things can happen. how to react quickly so that we can reschedule the production, minimizing the impact in the final production of the week. With this clear business interest to be addressed in the project, then what the specific contributions on knowledge were to produce that kind of finite capacity scheduling tool, first of all, and ingraining all those constraints that are not few. We are not going to show the deep extension of constraints, but they are quite a lot ones. The other point was to how to represent in a realistic way the production plan, how the machines behave, how humans behave. And here is where we have the digital twin working, a representation of the plan, what happens if a machine starts to delay, how it's going to impact, how to play with all that. How to use AI technologies for not only improving the scheduling from the point of view of the production, but also something that we are not going to show, but that is covered, is how to improve the prediction of the demand, so forecasting the demand, so we can also see the reliability of the schedule. And finally, to provide intuitive interfaces using the DSS introduced by Alexandros before. So with that, 3 different demos that we are going to show. One is this one, that is the set of, we provided a simulator for doing for playing what if scenarios for the production scheduling. So let me play the video. So a little bit, probably you will have more information in the test that is appearing, but basically that interface is useful in the sense that in the very top you have different inputs that are things such as, for example, you can pick the different priority rules that are written there. Priority rules meaning, for example, what kind of different scenarios you want to evaluate. Things like, I prefer to cluster the different yogurts to be produced by customer priority or by cost or by color of the fruit of the yogurt and things like that. In the middle, you can see the rules in some kind of technical language. And then down, you can see the different results. One possibility that has the tool is to play different rules in the historical information, the inners or the technological background that has the tool is that discrete event kind of type of simulation, and what you can see is that you can play in a slow motion how the algorithm is assigning the different orders, that is what is shown here sequentially in the different machines. In the left, you can see the machines. These are the different machines in the line, and here is the time. Sorry, Marta. And then you can play how the different schedules that the machine has computed in quite fast are scoring in the different parameters that they define, such as amount of scrap, picking one. I am going to post that part because it's more a technical part, but such as amount of scrap, time to finish, and things like that, because you don't have a unique objective. Maybe you want to reduce the scrap, even if it takes a little bit longer to finish the production. So that was the first one. Then the second one is an alternative solution using AI. So Marta will explain this part.
Can provide more detail. In this scheduler, the algorithm that is running in the background is different. It's a constraint optimization problem. So the goal here is to minimize a function. As input, we will receive the list of the orders. That means the yogurts that we want to schedule. Also the quantities for when we want to have this production ready, the deadline. And apart from that, the data that is coming from the factory. That means how many machines do we have, the cost, the times that we need to produce each yogurt, and also the speed of the machines. Here we have more details about the model itself. So we have defined several constraints, and the function that we want to minimize, that in that case is the monetary loss, which means the amount of money that we use to produce a schedule. This is actually related to the amount of scraps and also of the time that we need to produce the list of orders.
So 1 second only.
Yes.
That is that so far the thing that is really different in this approach is this model, because the model is AI oriented. By the previous inputs and the problem itself is common to both of them. Not
Production scheduling, exactly. But the algorithm, it's different.
It's different, the approach.
Yes. Here in this snapshot, we have an example of the output of the model. So we provide a list of solutions. For each solution, we have the assignation of each order to each machine and from which time it starts and which time it ends. In the end, also, we can see here the loss, the resulting loss to compute this overall schedule. So the good thing of this model is that you can retrieve several solutions that are computed in parallel. So you can introduce several optimizations in order to execute the model really quickly. So the model in the end converge faster than a non-AI maybe solution can in the end convey. Now I will switch to the demo. So in order first to launch any scheduling, you have to use the API. This API is connected to the digital twin that Victor just showed. So let me just run through the process. I cannot see it. Yeah.
And you say the pattern is so small.
Yeah, it's small. Not sure if it's yes. So first, as I said before, we introduce the data for this particular scheduling and then all the data that is coming from the factory. Of course, depending on the factory, this data can be changed. We also have the possibility of retrieving the data from the historical data storage or using static data. Here we see how the model look like and also the input data. These are the values to compute in the cost of the amount of scraps, the time, and some of the constraints of the model. In the end, as I said before, the goal is to minimize the monetary loss. Then we start the process, and we will see that we start to explore the search space. This is like some kind of tree, I would say. The leaves of the trees are the variables that are set to some value. If the value is red, means that this value is not right. So we need to try another solution. Every branch is a solution. So we can see that some of them, they are not actually correct. And others, they do finish. These are the ones that we see here. And they are sorted by the amount of loss. We have to keep in mind that this is an optimization problem. So depending on the amount of data also can take longer. Then this information is sent back to the digital twin that will show in a 3D way all the results. Also, I think really let the user to choose which one of the solutions they want to apply for. And this is it.
Okay. So these two were meant to be covering the part of the action schedule, and the demo that was shown, this one, in 1 sec, was meant to be the backgrounds. Now you will see the interface. The point is that the previous one was meant to be for the schedulers, and this is for the problem of what happens then when you have the schedule already and the schedule is run, in the shop floor, and then the operators are, beside the machines and reacting to what happens then in the actual production. So what we see here is the digital twin framework and one specific digital twin. The reality is that you can have several digital twins. This is the view that the operator has, The cockpit is, customizable. One thing that they can have is a 3D representation of the shop floor itself. You can see this like augmented view where they can see if things are happening, if the data is being uploaded by the set of parameters that you have defined. They can see the initial demand, the actual production, meaning what has been produced till today, from this week, from this previous schedule. And then what they can do is to compute the pending demand, what is pending to be done to comply with the initial schedule. They see a view of the schedule that was proposed by his or her scheduler. We provide within this framework the possibility to add also visual widgets to have a similar representation to the one that was shown to the scheduler with additional information. And the relevant part is that they can play with different kind of, functionalities for simulating what happens if a machine fails. Here we are simulating that this machine Hamba 2 fails. We have switched it off. In reality, you don't have that buttons, but the machine actually fails. And then in addition to have an alert, obviously you can change, for example, the way that you want to prioritize the rest of the pending demand that has not been produced, or you can keep it. But the point is that you click on reschedule and you get the pending demand, a schedule of the pending demand. Mean that in this example, for example, you will see that the Hamba 2 is not visible. There are no works assigned to Hamba 2. And then you will see like a Gantt representation again on how the rest of the demand can be pushed into the working machines. As one specific yogurt or order can be produced in different machines, maybe there is an existing machine. In this case, I think that the algorithm picked Hamba 6, I don't remember exactly, but it picks a different machine that where they didn't, the algorithm was not assigning so much works to assign the new work and to try to catch up with the rest of the production. So, in a very succinct way, we have presented the 3 of the more additional demonstrations that we have. The impact that we are causing in Parmalat are affecting to several of the goals that we defined for this specific one, for this specific industrial pilot. One of them being if the algorithms that we are generating are improving, for example, the OEE, that is an indicator for being how good are we, using our own resources. Things like how quick we act on unexpected events, for example, if we are also reducing the scrap, if we are reducing the setup of the machines, things like that.